When you watch a tug of war, it's like the ultimate binary contest.
Oh, absolutely.
There's just this thick rope, a line drawn right in the mud, and two teams just pulling and straining until one of them finally collapses. It's totally a zero-sum game. I mean, someone wins, someone loses, and it is incredibly straightforward to watch.
And for literally a century, that is exactly how we pictured human psychology.
Yeah.
Like on one side of a rope, you have your DNA, your biology, and on the other side, your parents, your upbringing, your culture.
The ultimate tug of war.
Exactly.
But what if the rope doesn't actually exist? What if the opposing teams, the mud, like the entire contest is just this massive illusion? Welcome to the deep dive, everyone. Today we are dismantling one of the most famous phrases in human history. We are tossing out nature versus nurture and replacing it with something infinitely more fascinating and, frankly, way more scientifically accurate. The modern concept is no longer nature or nurture. It is nature via nurture.
Yeah, they aren't competing explanations fighting for credit anymore. They are basically inseparable inputs to the exact same developmental process. You literally cannot have one without the other.
Okay, let's unpack this. Our mission for today's deep dive is to answer a really fundamental question for you guys listening. What actually causes mental illness? We're looking at this incredibly comprehensive stack of research covering the history, the science, and the clinical reality of how our biology and our experiences intimately collaborate.
Right. But before we get to the modern science, we kind of have to look at the historical damage caused by keeping them apart.
Yeah, it wasn't pretty.
No, not at all. Treating genes and environment as a competition, it wasn't just like a scientific error. It caused profound human harm.
It really did. And going through the sources, I was surprised to see how old this debate really is.
Oh, the urge to separate them is ancient. I mean, Shakespeare actually coined the contrast back in 1611 in The Tempest.
Oh, wait, really?
Yeah.
Shakespeare?
Yeah, he described a character as a born devil on whose, quote, nature, nurture can never stick.
Wow.
Yeah, but the phrase didn't actually enter the scientific vocabulary until the late 19th century. There was this guy, Francis Galton, who was actually Charles Darwin's half-cousin.
Talk about genetic pressure in the family.
Right. Well, he was trying to figure out why highly eminent, successful scientists tended to run in families. And to tease apart whether it was, their heredity or their upbringing, he pioneered the use of twin studies.
Which is actually a brilliant method. I mean, it's still central to genetics today.
It is brilliant. But unfortunately, he took his nature-leaning conclusions to a very, very dark place.
Yeah, the sources get pretty heavy here. Galton actually coined the term eugenics.
Yes, he did.
He argued for the selective breeding of humans.
Yeah.
And, that wasn't just some abstract academic theory that stayed in the textbook. That idea fed directly into forced sterilization laws all across the United States.
It's awful. The Supreme Court actually upheld those laws in the infamous 1927 Buck v. Bell ruling.
I couldn't believe reading that.
Yeah, over 60,000 Americans were involuntarily sterilized because they were labeled with supposedly inherited feeble-mindedness. The government basically decided their genetic nature was flawed, so their reproductive rights were just permanently erased.
Yeah, and it didn't stop there, right?
Yeah.
Those same ideas were eventually studied and just weaponized to genocidal extremes by Nazi Germany's T4 program.
Exactly, which specifically targeted people with mental illnesses and disabilities.
It is just the absolute starkest historical misuse of the nature argument.
It really is.
But, what often happens in science when one extreme leads to a tragedy is that the pendulum swings violently in the opposite direction.
Totally.
So moving into the mid-20th century, we get behaviorism, basically the nurture-only extremism.
Right, and the leading figure there was John B. Watson. He famously boasted in the 1930s that if you gave him like a dozen healthy infants, he could take anyone at random and train him to become literally any type of specialist.
A doctor, a lawyer, a thief.
Exactly, regardless of the child's talents or ancestors.
Which, that sounds incredibly arrogant to us now. It just completely ignores biology.
It treated the human brain as a completely blank slate. And that nurture-only mindset, it shaped psychiatric theory for decades, leading to these deeply destructive theories that place the entire burden of severe mental illness squarely on the shoulders of parents.
This part of the source material was just heartbreaking to read. You have psychiatrists in the late 1940s popularizing this idea of the schizophrenic mother.
Yes.
The theory was literally that a cold, rejecting mother physically caused schizophrenia in her children.
And then you also had the refrigerator mother theory of autism,
Right.
arguing that unloving mothers were the direct cause of their child's autism.
Which is just wild because we now know unequivocally that both autism and schizophrenia are heavily neurodevelopmental and genetic in origin.
Absolutely. If you look at the brain architecture and the genetic loading, there is zero empirical support for parenting style causing these conditions. None.
But for decades, parents, and especially mothers, were just crushed with guilt.
Told by medical professionals that their lack of warmth broke their child's mind. It's devastating.
It's like a catastrophic courtroom trial where the jury decides to just hang either the biology or the parents before even looking at the actual evidence. Why was the scientific community so desperate to find a single, simple scapegoat for mental illness?
Well, if we connect this to the bigger picture, human nature fundamentally craves simple, deterministic answers.
We want an easy target.
Right. We want a clear villain. If the villain is a bad gene, we can theoretically isolate it. If the villain is a bad parent, well, we can blame them and try to perfectly control our own parenting. It gives us this illusion of control over the terrifying randomness of illness.
That makes a lot of sense.
But the eugenics movement and the refrigerator mother theories, they are now taught as cautionary tales in psychiatric training. They prove that single-cause extremism doesn't just produce bad science. It produces real, measurable human trauma.
So the pendulum swung from nature to nurture, causing devastation on both sides. How did modern science finally stop the swinging and actually find the middle ground?
The breakthrough came through advanced statistics, basically, and a complete reframing of behavior genetics. A really key milestone was when researchers formalized what are known as the 3 laws of behavior genetics.
Okay, break those down for us.
Sure. So Eric Turkheimer put these forward around the year 2000. The first law states that all human behavioral traits are heritable to some degree. Nothing is entirely a blank slate.
Okay, biology always has a seat at the table.
Exactly. The second law states that growing up in the same family actually matters less than being genetically related.
Which I have to say is a pretty tough pill to swallow for parents who think they're sculpting their child's personality from scratch.
It is. It really is. But the third law is the crucial one. It says a massive portion of the variation in complex traits is explained by neither genes nor shared family environment, but by unique individual experience.
So your specific traumas, your specific relationships.
Right, the unique life you live outside of your family unit.
And this introduces a word that causes so much confusion when we talk about mental health, which is heritability. The source material highlights a massive misconception here.
Oh, huge.
When someone reads an article that says, schizophrenia is 80% heritable, they immediately think, oh, 80% of that specific person's illness came from their genes and 20% came from their environment.
And that is completely false. Heritability is a population statistic. It describes how much of the variation in a trait across a whole group of people is statistically associated with genetic differences.
Okay, give us an analogy to picture this.
Okay, imagine a field of wheat. If you plant genetically diverse wheat seeds in the exact same soil with the exact same sunlight and exact same water, any difference in their height is 100% heritable.
Because the environment is identical.
Exactly. The variation is entirely due to the seeds. But if you take genetically identical seeds and plant some in rich soil and some in sand, the variation in height is entirely environmental.
So heritability is not a personal fortune-telling number.
Not at all. You cannot apply it to an individual case.
It doesn't mean your destiny is 80% written in stone.
Right. And the best proof of that comes from Irving Gottesman's landmark twin studies on schizophrenia. He looked at identical twins who, share 100% of their DNA.
Yep.
He found that if one identical twin has schizophrenia, the co-twin develops it roughly 48% of the time. Now compare that to fraternal twins. For them, the rate is only about 17%.
Okay, wait, here's where it gets really interesting. I need to stop you at identical twins.
Sure.
If they share 100% of the exact same biological code, how on earth is the schizophrenia rate only 48%? Like, where is the other 52% coming from, if not the DNA? Shouldn't it just be a 100% guarantee?
See, that 48% gap is the ultimate smoking gun that genetic risk is probabilistic, not deterministic.
It's a probability.
Right. The fact that more than half of genetically identical co-twins do not develop the illness is incredibly powerful evidence. Genes alone do not decide the outcome. They just set the stage.
So the rest of the risk comes from?
It comes from those unique individual experiences we mentioned earlier. viral infections during pregnancy, complications at birth, specific psychological traumas later in life.
Okay, so if the DNA is just setting the stage, there has to be a physical bridge,
Right.
right? Like between a traumatic experience and a biological reaction. How does an invisible emotion or a stressful event physically pull a genetic trigger?
That is the million-dollar question. And the first major conceptual bridge for that was the diathesis stress model, which was proposed back in the late 1970s. Diathesis is basically a medical term for a biological or genetic vulnerability.
Let me throw an analogy at this to see if I've got it. It's like a loaded mousetrap, right? The diathesis, the genetic vulnerability, is the coiled spring.
Okay, I like this.
It is sitting there storing tension, but it's completely harmless on its own. The stress, the environmental factor, is the mouse actually stepping on the trigger.
That is exactly how it operates. A person with a very high genetic loading for depression, so a very tightly coiled spring, might only need a mild stressor, like a minor setback at work, to trigger a major depressive episode.
Wow.
But someone with a low genetic loading, a loose spring, might require a catastrophic life event to trigger depression, or, they might never become ill at all.
Which completely dismantles that single cause thinking.
Yeah.
It's never just the trap and it's never just the mouse. It's the interaction of the two.
Exactly. And this logic drove an explosion of research into what we call gene-by-environment interaction, or GXE. Scientists really wanted to see this happening at the molecular level.
And there was a famous study on this, right?
Yeah, one of the most famous early attempts was a longitudinal study in New Zealand by Avshalom Caspi. They basically tracked 1,000 people from birth, and they focused on a specific gene that helps transport serotonin in the brain.
And this gene comes in a short version and a long version.
Right. And what they found was that people carrying the short gene variant were much more likely to develop depression, but only if they had experienced childhood maltreatment or severe stressful life events.
Okay, so for the people with the short gene who had peaceful, low-stress lives.
There was no elevated risk of depression whatsoever.
That is wild.
Yeah. The short variant basically makes the brain's serotonin system a bit less efficient, meaning the brain is more reactive to threats. But the gene didn't manufacture the depression out of thin air. It simply increased the brain's biological sensitivity to the environment.
So if you're listening right now and wondering why you maybe reacted to a highly stressful work environment completely differently than your colleague did, this is the exact mechanism at play. Your colleague might literally have a different biological sensitivity to that exact same stress.
Yes.
And the sources are very, very clear on this. We have to mention a massive caveat about that specific serotonin study, because it shows how science actually self-corrects over time.
It does. It's a great example of that. Later on, massive meta-analyses analyzing tens of thousands of people failed to fully replicate that clean, simple finding.
Which happens a lot in early genetic research.
It really does. But that doesn't mean gene-environment interaction is fake. It just means that early studies were searching for a single dramatic depression gene. And we now know that virtually all mental illnesses are highly polygenic.
And polygenic meaning many genes.
Exactly. Thousands of them, actually. We spent a decade hoping to find, one or two genetic typos that caused schizophrenia or depression. But when we sequence the genomes of millions of people, we find that these conditions are linked to thousands of different genetic locations across your entire DNA.
And each one just contributes a tiny bit.
Right, maybe a fraction of a percent to your overall risk.
So it's not one massive tidal wave. It's a million tiny drops of water filling up a bucket.
Beautifully put.
Which pushes researchers toward polygenic risk scores, basically aggregating all those thousands of tiny effects instead of hunting for one smoking gun.
Right.
But even with polygenic scores, we are still just talking about the underlying code. The most profound mechanism bridging nature and nurture is epigenetics.
Oh, epigenetics is incredible. It is the literal mechanism of how the environment changes how your genes are read without changing the underlying DNA sequence itself. It essentially proves the environment has a biological pen.
The rat studies on this are absolutely mind-blowing.
The Michael Meany studies, yes.
Yeah, neuroscientists looked at how mother rats raise their pups. Some mothers naturally engage in high amounts of licking and grooming, very nurturing behavior, while other mothers essentially ignore their pups.
And they found that this maternal nurturing, or the lack of it, caused permanent chemical modifications on the gene that controls the stress hormone receptors in the pup's brains.
And the specific process they observed is called methylation.
Exactly.
I want to break down how methylation actually works physically because, honestly, epigenetics can sound a bit like magic.
It really can.
So imagine your DNA is a massive, complex soundboard in a recording studio. The hardwired circuitry beneath the board, that's your genetic code. You cannot change the wiring, you are born with it.
Right.
But your environment, like the mother rats licking and grooming, those are the physical fingers sliding the volume faders up and down on the board.
I love that analogy. And methylation is the physical locking mechanism on those faders. So a methyl group is basically a tiny cluster of carbon and hydrogen atoms. In response to the environment, these clusters physically attach themselves to the DNA strand. They act like bulky padlocks, physically blocking the cell's machinery from reading that specific section of the gene.
What's fascinating here is that the environment physically rewrites the operation of nature.
Literally.
In the high-nurturing mother rats, the grooming literally removed those padlocks from the stress receptor gene. It turned up the volume on building receptors that help shut down the stress response.
Right, so those pups grew up to be calmer, less stress-reactive adult rats.
Meanwhile, the ignored pups kept the padlocks on. They couldn't build enough receptors, so they grew up to be highly anxious adults, easily overwhelmed by stress.
It just shows the strict boundary between biology and experience is a total illusion. The experiences you have leave chemical signatures on your genome that dictate how your brain and body actually operate.
Which brings us directly to the clinical reality.
What?
Why this matters to you, listening right now. I mean, this isn't just an abstract academic debate about rats. This integrated science heavily shapes how our healthcare system actually treats mental illness today.
Absolutely. Think about it. If a clinician treats a disorder as purely biological, they might just prescribe heavy medication and completely ignore therapy, social support, and trauma-informed care.
Which leaves a lot of healing on the table.
Exactly. But on the flip side, if they treat it as purely environmental, they might blame the family dynamic and completely miss a life-saving medical intervention for a neurodevelopmental condition.
And that is exactly why the standard framework taught in psychiatry residencies today is the biopsychosocial model.
Right, introduced by George Engel back in the 70s.
It demands that biological vulnerabilities, psychological coping mechanisms, and social environments all be assessed together. They are equally valid pillars of a patient's health.
And on the public health side, we have the ACE study, Adverse Childhood Experiences, which made the nurture half of the equation incredibly concrete and measurable.
Yeah, this was a massive study looking at things like abuse, neglect, household dysfunction, or even having an incarcerated parent. It wasn't just measuring vague, general stress. It was measuring very specific traumatic events.
And what they showed was a literal staircase effect, a dose-dependent relationship between childhood adversity and adult mental and physical illness.
So the higher the dose of trauma,
The higher the risk for depression, suicidality, and even autoimmune diseases and heart disease later in life. The body literally keeps the score of the environment. And that realization is exactly what drives trauma-informed care initiatives in schools and social services today. We aren't just managing bad behavior anymore, we are managing biology that has been sensitized by trauma.
knowing that mental illness is an interaction of vulnerabilities and stress, it just systematically destroys the stigma. It completely erases those cruel labels of bad genes, bad parenting, or, personal weakness. So what does this all mean?
Well,
If our mental health is this massive tangled web of thousands of tiny gene variants interacting with every stressor we've ever faced, does that make treating mental illness hopelessly complicated? Or is it actually a message of hope?
I think it is profoundly hopeful.
Really?
Yeah, one of the biggest, most dangerous misconceptions we see is this idea that if a condition is highly heritable, it means therapy or environmental changes won't matter.
Right. People think, well, it's in my genes, there's nothing I can do.
Exactly. But epigenetics proves that is categorically false.
Because the environment changes gene expression.
Yes. If trauma and neglect can place restrictive padlocks on your DNA, then positive environmental changes like intensive therapy, exercise, strong social support, and community connection can physically alter those biological outcomes too.
That is so empowering.
You can change how your genes are expressed. You are never simply a prisoner of your DNA sequence.
We've covered massive ground today. We moved from Shakespeare's poetry and the tragic era of eugenics to behaviorism's overreach and the immense human toll of mother-blaming theories.
We covered a lot, yeah.
We really did. We explored how modern statistics redefined heritability, proving that genetics is about probability, not destiny.
And we saw how the diathesis stress model, the loaded mousetrap, rewrote our understanding of risk, how polygenic scores replace the myth of the single depression gene, and how epigenetics proves that nurture physically reshapes nature at the molecular level.
It all permanently buries the idea that nature and nurture are in competition.
It really does.
But before we go, there is one final concept from our sources that just lingers in the back of the mind, and it kind of flips this entire dynamic on its head.
Oh, yes. It's a phenomenon called gene-environment correlation, or RGE for short.
Right.
We've spent this entire time talking about how the environment affects genes and how genes react to the environment. But RGE describes how our genetic tendencies subtly shape which environments we actually seek out, or even the reactions we evoke from other people.
Kind of like a feedback loop.
Precisely. A temperamentally difficult child, driven by their genetics, might unknowingly evoke harsher, more frustrated parenting, which then serves as an environmental stressor that reinforces those original genetic tendencies.
Wow.
Or, a person with a genetic predisposition for sensation seeking might actively place themselves in high-stress, risky environments that trigger other biological vulnerabilities.
Which makes separating the two utterly impossible.
This raises an important question, and it's something I want everyone listening to think about. If your genetic tendencies subtly drive you to seek out specific environments, to what extent is your nurture actually just an extension of your nature?
It is deep.
Are you passively experiencing your environment, or is your biology quietly, invisibly building the very world that will eventually trigger it?
That is definitely something to sit with. Next time you see a tug of war, remember the mind isn't two teams fighting over a line in the mud. It's the mud, the rope, and the teams, all weaving themselves together into something entirely new. Thank you for joining us on this deep dive, for bringing your curiosity, and for questioning the world alongside us. Keep asking those big questions, and we will catch you next time.